Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question extracted from 2018 Time Zone 0 in November. So that is question number 1, something deal with mole calculation, a standard class of question asking for mole calculation. Let's see, asking how many moles of the iron 2 sulfide, so FeS2, are required to produce 32 grams of the sulfur dioxide. So given the relative atomic mass of sulfur going to be 32 and oxygen to be 16, and given to the balance equation between the reaction, right? So obviously now our target is to find out the moles of this iron sulfide, so FeS2, and also with the comparison with the relationship with this SO2. So normally, remember, whenever handling this class of question, the given information is not referring to our target. Remember, we have the 3 steps approach. I simply call it 3 steps approach, APPRACH, right? So which means we only need to follow these several 3 steps. The first step is to work out the moles whenever it is given. Just like this case, we are now first given the mass of SO2. So meaning we can first work out the moles of the SO2 simply by the equation mass over molar mass, right? So then we can make good use of the equation, so deal with the what we call mole ratio. So do remember the coefficient. Now don't call it coefficient anymore. So this is the first level. The 4 and 8 in this balance equation is what we call mole ratio, which means 4 moles of this FeS2 should give rise to 8 moles of the SO2 when there's a balanced situation, when there's a complete conversion. So that's why this is what we should make good use of the second step. Then we should finally arrive to the final, which is the moles of our target. So that's why you can see the bridge between the given information and the unknown information is what we call the ratio, the mole ratio, to be 4 to 8, or simply known as 1 to 2. So that's why the first step, we follow the rules. First step, we calculate the moles. So what moles can we be calculating? Of course, the moles of SO2. So given mass over the molar mass, so which is going to be 32, over, then using some mathematics, sulfur 32, oxygen going to be 16, but 2 of it, so also 32. So double 32, we have 64, right? So 32 divided by 64, which is going to be 0.5 moles, right? So at the very first beginning, we arrived to the first thing, which is the moles of the given situation, which is the SO2. Then what's the next step? Mole ratio. That means the bridge between the SO2, which is now we know 0.5 moles, with our target, which is FeS2, which is going to be this coefficient, right? Again, don't call it coefficient anymore, but now we call it mole ratio. So 8 to 4 simply means 2 to 1. So here will be 2 portion to 1 portion. So 0.5 portion will then be related to divided by 2, right? So simply means 0.25 moles, right? So at the end, already we arrived to the answer, which is going to be 0.25. Because what are they asking? Just directly the moles of the FeS2. So that's why obviously the answer for this case will be A.